important properties of triangles. Now, in the last class, we learned two important properties of triangles. Can you recall? The first one that we learned was exterior angle property, and the second one was angle sum property of triangles. Okay, now let's quickly recall exterior angle property. Now I have given you a triangle here, x, y, z, and xz is extended. The line passes through M. So the exterior angle is formed at MZY. Okay, so according to the property, angle MZY, that is this angle MZY is equal to sum of angle Y and angle Z. That is the property, exterior angle property of a triangle. So, angle MZY is equal to angle X plus angle Y. Here, I read X as angle X and Y as angle Y because now they are independent of any more angles here. So, I can read it as ZXY or simply angle X. Similarly, angle Y can be read as ZYX or simply angle Y. Okay, next. The second property that we learned was angle sum property. According to that property, the sum of the three angles of any triangle is equal to 180 degrees. Children, you can check practically. Draw any triangle in your notebooks. Then place the protractor here at this point. Measure this angle. Place the protractor here. Measure this angle. And place the protractor at this vertex and measure this angle. After measuring the three angles, sum them, that means add them. You will find that whatever may be the triangle, the sum of the three angles will be 180 degrees. Okay, you can do that, prove it practically. Okay, now in this triangle ABC, angle A plus angle B plus angle C is 180 degrees. So these two are the properties that we learned in the last class. Let's move on and learn few more properties, two more properties actually in this session. Okay. The property 3 states sum of any two sides, sum of any, triangle has three sides, sum of any two sides of a triangle is always greater than the third side. I hope it's clear. Sum of any two sides, is always greater than the third side. Okay, let's see what we mean by that. Now, the triangle is ABC here. According to that property, if you measure AB, BC and AC, okay, that means according to the property, if you add AB plus BC, their total or the sum should be always greater than the side AC. Similarly, if you add AB plus AC, their sum should be greater than BC. Likewise, if you add the remaining two sides, it has to be greater than the remaining side. So that is the third property. What does it say? It says sum of any two properties of a triangle is always greater than the third side. Okay. Now, I hope this is clear. So AB plus BC is greater than AC. Where is AB? This is AB plus BC will be greater than AC. Likewise, BC plus CA is greater than AB. Similarly, AB plus AC will be greater than the third side, that is BC. Okay? Now, let's see how this can be proved. So, in triangle, in the figure, that is in triangle ABC, 3 plus 5 is greater than 4. You all agree? So 8 is greater than 4. Similarly, 5 plus 4 is greater than 3. Likewise, 3 plus 4 is greater than 5. I hope children you understood. What we mean is, here 3 plus 5 is 8. 8 is greater than 4. 5 plus 4 is 9. 9 is greater than 3. 3 plus 4 is 7. 7 is greater than 5. This is the third property that we have learned today. Okay? Sum of any two sides is always greater than the third side. Okay? So, I hope that's clear. 8 is greater than 4. 9 is greater than 3. 7 is greater than 5. Okay? Now, only if the above condition is satisfied, it is possible to construct a triangle. Children, listen carefully. Only if this condition is satisfied. Okay? Only if this condition. What condition? Sum of any two sides is always greater than the third side. Only if that condition is satisfied, okay, you can construct a triangle. Okay, so that is third property. Please learn it by heart and try to prove it practically by drawing many triangles and measuring and checking. Okay. Now, in exercise 6.4, we have two means. Is it possible to have triangles with the following sides? Now, just now you have learned the third property, which says that, try to recall and repeat, children. The sum of any two sides of a triangle is always greater than the third side. That's the property we learned just now, is it not? Now, let's see if that is satisfied here. Now, in the first case, 2 plus 3, how much is 2 plus 3? 2 plus 3 is 5. So, 5 is equal to the third side. We are trying to prove if we can construct these triangles. Okay. Next one, 3 plus 5 is greater than 2. I hope you all agree. 2 plus 5 is greater than 3. Fine. So, now you tell me, can we construct this triangle? We cannot, because 2 plus 3 is not satisfying the condition. What is the condition? It has to be greater than the third side, but here it's equal to the third side. So, this triangle cannot be constructed, meaning we cannot have a triangle with these measurements. What are they? 2 centimeters, 3 centimeters and 5 centimeters. So, we cannot construct a triangle with these parameters. Okay, children. Now, let's see the next one. 3 plus 6 is 9, is it not? So, 9 is greater than 7. 6 plus 7 is 13. 13 is greater than 3. 3 plus 7 is 10 and 10 is greater than 6. So, yes, we can construct a triangle with these measurements. So, a triangle can have these measurements and we can construct a triangle with these measurements. Okay. Now, let's see the third case. 6 plus 3 is greater than 2. 3 plus 2 is greater than 6. And 6 plus 2 is greater than 3. So, yes, we can construct this triangle also. So in this case, it is no, we cannot construct, we cannot have a triangle with these measurements. This is a yes, and this is also yes. A triangle can have these and these measurements, but it cannot have these measurements because it's not satisfying the condition that sum of any two sides should be greater than the third side. Okay. Now, take any point on O on the interior of the triangle. Okay, take any point O on the interior, okay, of the triangle, and name the triangle as P, Q and R, and interior point is O. Now, is OP plus OQ greater than PQ? Now let us see. We have to do a small construction here. Simple. Join OQ, OR and OP. Okay, children. Now, the question is OP plus OQ greater than PQ? Where is OP? This is OP, is it not? OP plus OQ, is it greater than PQ is the question. Yes, it is. That's why we were able to construct this triangle. Okay, that's why you were able to join these and you got a triangle. That means it proves that sum of these two sides is greater than the third side. Likewise, the next question is OQ. Is OQ plus OR greater than QR? Yes, because you can clearly see this is a triangle. Okay, so it is possible. The next one is OR plus OP is greater than PR or RP. Yes, because you can see with this point inside the triangle, we could still draw or construct three triangles. Here you have one triangle, here you have one, and here you have one. So all these conditions are satisfied. So you can write yes, here also yes, and here also yes. Did you understand? Next. Now let us see two important types of triangles. We have already learned in classification in the previous session. We learned about the various types of triangles, that is based on sides and angles. So based on sides, we learned equilateral triangle, isosceles and scalene, and we also learned why they are called equilateral, isosceles and scalene and what the conditions are for them to be called the equilateral, isosceles and scalene. Also based on angles, you learned acute angle triangle, right angle triangle and obtuse angle triangle. Now let us learn in detail what this equilateral triangle is. Now, a triangle in which all the three sides are equal. Remember, all the three sides are equal. That is called equilateral triangle. I hope you all can recall that definition. Now, an equilateral triangle is also equiangular. What it means is, in the previous class we learned, if three sides are equal, automatically the three angles are equal. Okay? So, in an equilateral triangle, all the sides are equal. So, all the angles are also equal. So, equilateral triangle is also called equiangular, meaning all angles are also equal and each angle measures 60 degrees, children. Do you all agree? Please recall the second property that we have learned. The sum of the three angles is equal to 180 degrees. So in an equilateral triangle, we have 60 degrees plus 60 degrees plus 60 degrees. What is the total? 180 degrees. Is it not? So that condition is satisfied. Okay? Now in front of you, you can see on the screen an equilateral triangle. How did we come to know this? Remember children, in the previous class we learned, look at, even though the measurements are not given here, see, the measurements are not mentioned, still we can claim that this triangle is equilateral because you can see 2 strokes, here also 2 strokes, here also 2 strokes, meaning that this triangle is an equilateral triangle. Okay, the next triangle, you can see here, instead of marking with strokes, he has clearly mentioned this side measures A units and A units. Okay, practically you can think maybe we can call it 5 centimeter. That means instead of A, I am writing 5 centimeters. Okay, that means all the 3 sides are equal. Okay, so this is an equilateral triangle. Also, you can see he has mentioned the angles. This angle is 60 degrees. Angle A is also 60 degrees. Angle C is also 60 degrees. What does it mean? If you add 60 plus 60 plus 60, the sum is 180 degrees. So, even by looking at the angles, we can clearly mention that this triangle is equilateral triangle. Okay, so 60 plus 60 plus 60 is 180 degrees, showing that the given triangle is an equilateral triangle. Okay, next. Remember an isosceles triangle? In equilateral, if all the sides and angles are equal, in isosceles triangle, 2 sides, any 2 sides are equal, so the corresponding opposite angles will be equal. What we mean is, if 2 sides are equal, automatically 2 angles become equal. So since the third side is unequal, there will be one unequal angle also. Okay, so what is an isosceles triangle? A triangle in which 2 sides are equal. That triangle is called an isosceles triangle. Okay. In an isosceles triangle, 2 sides have the same length. I hope you agree. Any 2 sides, children. And 2 angles opposite to equal sides are equal. What we mean by that is, now here you can clearly see ED is equal to EF. These 2 sides you can see marked by a single line, single stroke. These 2 sides, that is EF and ED, are equal. So the corresponding opposite angles, remember I told you if 2 sides are equal, 2 angles are equal. So angles opposite to equal sides are equal. That means angle D and angle F are equal to each other. Please listen carefully, children. ED, side ED is equal to EF. How do we know? We know because it's marked by these strokes. Measurement is not given, but some clue is given to us. Therefore, angle D is equal to angle F. I hope that's clear. Okay. In this triangle, let us prove practically if angles opposite to equal sides are equal. Now, you may wonder, only one angle is given to us. Only one angle is given to us. How do we find these two angles? It's very simple, children. Since one angle is given, the other two angles, because this is an isosceles triangle, we can boldly say this is an isosceles triangle. Therefore, this angle and this angle will be equal to each other. Then how do we go about finding them? Simple. When you have the second property, you remember, the sum of the three angles is 180 degrees. So, 24 degrees plus x should be equal to 180 degrees. Okay, let me show you. Angle sum property is 24. This is 24, children. This angle is 24. That's what I've written here. This angle is x. I've written here. This angle is also depicted by x. Why? Because these two angles are equal. So we have 2x. Okay. So what should be the sum? Sum should be 180 degrees. How do we know this? We know this because we have learnt angle sum property, meaning the sum of the three angles of any triangle is 180 degrees. That's what I've done here. Now, what I've done is this 24 should be subtracted from 180 degrees. I hope you all agree. So 180 minus 24 is 150 degrees. That means each of this angle, that is x and x, they should be equal, is it not? So each of them is 78 degrees. I hope all of you understood this, children. How we got 78 and 78? Using only one angle. Very simple. Because this is an isosceles triangle, the first hint we got is this angle, that is x here and this, they should be equal. It's so simple because sum of them is 180 degrees. After that, I removed the 24 degrees and divided 156 degrees into two parts. We got 78 degrees, that is x here is 78 and this angle is also 78. So 78 plus 78 plus 24 should give us 180 degrees. I hope this property is clear to you. Next, a right-angled triangle. Now let us see what is so special about this right-angled triangle. Now all of you know what a right-angled triangle is. A triangle in which one angle, one of its three angles, children. You all know triangle has three angles. One of the angle is 90 degrees. Then we call the triangle as right-angled triangle or simply right triangle. A triangle in which one of the angles is 90 degrees. Please keep in mind, one of the angles, any one of the angles is 90 degrees is called a right angle. Okay, a right angle, a triangle in which one of the angles is 90 degrees is called right-angled triangle. Okay, now in a right-angled triangle, please listen carefully, children. The side opposite to the right angle is called a hypotenuse. I think last year we have learned this. It is the longest side of a right triangle. The other two sides are called the legs of the right angle triangle. Now, please look at this figure. The side opposite to, what did we say? Side opposite to the right angle. Where is right angle? It's here. Now, which is the side opposite to right angle? This one. Okay, this side. So, that side is the longest side, children. It's the longest side. Okay, so this longest side is called hypotenuse. It's called the hypotenuse. Please check the spelling. It's called the hypotenuse. So the longest side of a right triangle is called hypotenuse. The remaining two sides, that is this side and this side, they are called legs, because this triangle stands on either this leg, or if you turn the triangle, it can stand on this leg. Remember, these two are called altitudes. Now this is called an altitude. If you turn the triangle, this also becomes the altitude. I hope you can recall what an altitude of a triangle is. Okay, now that is the height, and this is the base. Now since this triangle is standing on this base, this side is called the base, that is, this is called the base. Now if you turn the triangle, this becomes the base and this becomes the height, children. So please remember, the longest side, that is this side, is called the hypotenuse. How do we know? It is the side opposite to the right angle. Opposite to the right angle. Okay. So please learn, in a triangle, if one of the angles is 90 degrees, it is called a right angled triangle. In a right angled triangle, please listen, longest side is called the hypotenuse. The other two sides are called the legs. So depending on which side the leg is, the one is called base, the other leg is called height. Okay, now let's see what is so important about right angle triangle. Remember, very important, children, a triangle, this is a very, very important conclusion. A triangle can have only one right angle. What is the reason? Suppose we have two right angles, then what happens when you add all the three angles? The sum will exceed 180 degrees. So a triangle can have only one right angle. Similarly, a triangle can have only one obtuse angle. I hope that's clear. Okay. Next, Pythagoras property of a right angle triangle. Now, what is Pythagoras property and who is Pythagoras? I think all of you know who Pythagoras is. He was a Greek mathematician, a philosopher, a very famous person who proved a very, very important property of right angled triangle or right angle triangle or right triangle. Okay. Now, what does it say? Now, Pythagoras, a Greek philosopher of 6th century BC, is said to have found a very important property of right angled triangle. Now let's see what the property is. So according to Pythagoras property, in a right angle triangle, children, this is very important. Only right angle triangle. This property holds true only with right angled triangle. Now what does it say? It says the square on the hypotenuse is equal to sum of the squares on the legs. I don't know how many of you understood. Let me show you. Let us say this is a right angle triangle. Okay. Now, what he says is the square on the hypotenuse. I'll shortly tell you what square means. The square on the hypotenuse, you can imagine a square is sitting here. Okay. This square on the hypotenuse is equal to sum of the squares. There's one more square here and one more square here. So, the area of this square is equal to area of this plus these two squares. Okay, that is what Pythagoras property means. I'll show you. Now, all of you can see you have a right angle triangle in front of you and there are squares on each side of the right angle triangle. So the triangle, let us name it as A, B and C. You can identify AB and BC are the legs and AC is the hypotenuse. So in the figure, ABC is a right angle triangle. All of you agree because we have a right angle right here. Okay, it's depicted by right the 90 degrees. So we can say this triangle is a right angle triangle. Now, AC is the hypotenuse. Do you all agree, children? AC is the hypotenuse. AB and BC are the legs. So I am going to call BC as the base and AB as the height. Okay. Now, what does Pythagoras property say? It says AC squared is equal to AB squared plus BC squared. Children, last year you have learned how do we read exponential numbers. Suppose we have, say, a number 4. Now, 4, if I write a number above in that corner, this becomes an exponential number and we read it as 4 to the power 2. This 4 to the power 2 means 4 is multiplied with itself 2 times. So, this can be read as 4 to the power 2 or 4 square. 4 square. Similarly, AC square here means AC into AC or AC square. So AC squared is equal to AB squared plus BC squared. So geometrically, how we prove Pythagoras theorem or Pythagoras property is, if a square is drawn on the hypotenuse, on this hypotenuse, if you draw a square, so the area of this square should be equal to area of this square, that is this one and this one. Okay, I'll explain to you clearly. So far, I hope you understood. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So, exponentially, how do you read? AC squared, that is AC to the power 2. AC squared is equal to AB squared plus BC squared. Okay, so geometrically, what we do is AC squared. So there are 3 squares sitting on the 3 sides. Geometrically, we say area of the green square. Where is the green square? It's here. Area of this square should be equal to area of this square and area of this square. That property is called Pythagoras property. So here geometrically, area of green square equals area of blue square plus area of red square. Okay, so please remember this. Pythagoras property holds true only for right angled triangle. Okay, children? Next, let's see what the activity is. Check whether the given triangle is a right angled triangle. Now, let us see if the given measurements hold true for right angle triangle, because only if that measurements, if that statement is true, that triangle can become a right triangle. Okay, let's see what the parameters are. Now, this is the triangle. 3 centimeters, 4 centimeters and 5 centimeters. Okay. Now, here in this triangle, nowhere the right angle is mentioned. How are we going to prove it's a right angle triangle or not? only by checking if the Pythagoras property holds true. How are we going to check? We are going to write the squares on the hypotenuse and the legs and check. Okay. Now, 3 squared plus 4 squared is equal to 5 squared. Is it not? That is what is Pythagoras property. What is Pythagoras property? The square on this, that is 5 square, should be equal to 3 squared plus 4 squared. Okay. Now, 3 squared is 3 into 3, that is 9 children. Please remember, it's not 3 into 2, it is 3 into 3, because 3 squared or 3 to the power 2 means 3 is multiplied with itself twice, and the answer is 9. Similarly, 4 squared or 4 to the power 2 is not 4 into 2, but it is 4 into 4. How much is that? It is 16. So, 3 squared is 9, 4 squared is 16. So, we have 9 and 16. Now, what do we do? Now, let us see what 5 squared is. 5 squared is 5 into 5, that is 25. Now, according to Pythagoras property, 25 should be equal to 16 plus 9. 25 should be equal to 16 plus 9. Is it equal, children? Yes? Yes, it is equal. 9 plus 16 equals 25. That means square on the hypotenuse, that is 5 squared, is equal to 4 squared plus 3 squared. So, we can claim that this triangle, this given triangle, is a right-angled triangle. Okay. Thus, the given triangle is a right-angled triangle since it satisfies the Pythagoras property. How did we check? We checked if 5 into 5 is equal to 4 into 4 plus 3 into 3. That is 5 squared, 4 squared, 3 squared. We have squared the measurements. How did we square the measurements? 3 squared plus 4 squared. 3 squared is 3 into 3. 4 squared is 4 into 4. After finding the answer, we saw that 5 squared, that is 25, is equal to sum of these two. So 9 plus 16 is 25. So 25 is equal to 25. We can claim that this triangle is a right-angled triangle. Okay, we can say that the given triangle, that is PQR, is a right-angled triangle, children. Okay. Next activity. Determine whether the triangle whose lengths of sides are 3, 4 and 5 centimeters is a right angle. Okay. So the previous one is similar to this. So you can just directly solve it on your own. See how I've solved it. Okay. The given measurements are satisfy the Pythagoras property. So it's a right angle triangle. Likewise, we can have many more measurements. These three measurements, that is 3, 4 and 5, if they satisfy Pythagoras property, then they are called Pythagorean triplets. If they satisfy Pythagoras property, they are called Pythagorean triplets. What is the spelling? Pythagorean, okay, triplets. Okay, and only if they satisfy this Pythagoras property, they are called Pythagorean triplets. Okay. Now, so the previous two activities, the problems were the same, parameters are same. We can check for many more. Now, squares and square roots. I'll tell you why we are learning this. Numbers, squares and square roots. Now here children, please look at these numbers. These are natural numbers, okay? 1, 2, etc. These are natural numbers. So squares of numbers, what did we learn just now? 1 square. 1 square means 1 into 1. So square of 1 is 1 into 1. So 1 into 1 is 1. Then root of 1, root of this 1, how did we get 1? Because square root of that 1 is 1. Let me explain with the next number. Take the next natural number. Square of 2 is 2 into 2. All of you agree. 2 into 2 is 4. But what is root of 4? How did we get this 4? So this symbol is called root, children. Square root. If no number is written here, it means it is a square root. Simply if you have this symbol, it means it is a square root. Likewise, you can have cube root, fourth root, and so on. Here, no number is mentioned means it is a square root. So, square root of 4 is 2. I hope you understood. 2 square is 4. Square root of 4 is 2. Just the opposite. Okay. Next one. Take number 3. 3 square is 3 into 3. That is 9. So what is the square root of this 9? Simple. It is 3. How do we write? Square root of 9 is 3. 10. I have taken next number as 10. 10 square is 100. Square root of 100 is 10. I hope you are following, children. Square of 12 is 144. Square root of 144 is 12. Square of 20 is 400. Square root of 400 is 20. Square of 25, I have skipped some numbers here. You can try for all the numbers. 4 square, 5 square, 6 square, 11 square, 14 square. For anything, write the square and then the root. Okay, children? 25 square is 625. Square root of 625 is 25. 26, square of 26 is 676. Square root of 676. How did we get 676? Its root is 26. How do we write that? Square root. See how I am writing? Square root of 676 is 26. Children, please learn them and you try to find the squares of many other natural numbers and their square roots. You know now how to find the squares and how to find the square roots. Okay? Now, in exercise 6.5, that is in page 130 in your textbook, PQR is a triangle right angled at P. Right angled at P. If PQ is 10 centimeter and PR is 24 centimeters, find RQ. Find RQ. Very simple, children. How do we find that? Just now we have learned Pythagoras property. All we have to do is find the square of the legs. How do we find? Find the square of 24. Just now we learned in the previous slide what the square of 24 is and square of 10 is. Okay. After finding the squares, add them. Then you will get a number. If you find the root of that number, you will get the measure of this hypotenuse. This is the hypotenuse. How do we know it is hypotenuse? It is opposite to the right angle. Okay, children? Yeah. Now solution. According to Pythagoras property, QR squared. Where is QR squared? You can see it's here. This is QR squared. QR squared. That is QR. So we have squared. You can imagine geometrically there is a square sitting on QR. Okay. Exponentially we have written QR squared. So QR squared, according to the Pythagoras property, QR square equals PQ square plus PR squared. I hope you understood. PQ squared plus PR squared. Okay, but what is PQ squared? It is PQ into PQ. PQ into PQ. Let me tell you, children. If you multiply the number twice with itself, you get a square. The power becomes 2. If I multiply thrice, let's see what happens. If I write 3 into 3 into 3, the power becomes 3. If I write 2 into 2 into 2 into 2, then 2 is gaining a power 4. Children, please be clear. These are called exponential numbers. Okay? Now, but what is PQ into PQ? It is 10 into 10 plus 24 into 24. So 10 into 10 is 100 plus 24 into 24 is 576. The sum is 676. Now, QR squared is PQ squared plus PR squared. But PQ squared we got as 100, PR squared we got 576. Total is 676. So, QR is not 676, but QR squared is 676. Then how do I get QR? Simple. Just now we learned we have to find the square root of 676. Can you recall, children? What is the square root of 676? Yes? Try to recall. 25 square is 625. So square root is 25. So what is 26 to the power 2? That is 676. So QR equals 26 centimeters. Okay. Now this measurement, that is hypotenuse, is 26 centimeters. So what did we prove? We proved that square on the hypotenuse is equal to square on the legs. Squares on the legs. That is Pythagoras property. I hope it's clear to you, children. Now, the next problem. All these are in your textbook exercise. A 15-meter long ladder reaches a window 12 meters high. Look at this problem. You have seen a wall. This is a wall, children. This is the ground. Okay. Now this ladder you might have seen. You all have seen ladder, is it not? It's placed in such a way that it reaches this window 12 meters. This window is 12 meters above the ground level. Okay. Now find the distance between foot of the ladder, that is this, and the wall. Okay. Now this wall, the angle between this wall and the floor is 90 degrees. Okay. You can imagine you are in your room, wherever you are sitting. Just imagine that corner where the edge where the wall meets the ground, it is right angle. And imagine you have placed a ladder. Okay. Now, so that is the right angle. So given ABC is a right triangle, according to Pythagoras property, I think now you are all very, very clear with that. AB squared plus BC squared is equal to AC squared. In the previous problem, the measurement of the legs was given and you found out hypotenuse. Now, hypotenuse is given, height is given, you have to find the base, children. Let's see how to find that. Now, AB squared is 12 squared. I think now you're all familiar. So, 12 squared, that is 12 to the power 2 square on 12 plus, I have written A squared because now this BC is represented by A units. Okay. Now, that is equal to 15 squared. That AC squared, remember children, this is the hypotenuse. In this problem, hypotenuse is given, height is given, we are finding base. Okay. Now, but what is 12 squared? It's 144. 15 squared is 225. You all know how to do it now. Okay. Now, 144 plus A squared is 225. Do you all agree? 12 squared is 144. A squared I have written as it is because we don't know this measurement. 15 squared is 225. Now, let us see how to find this A squared. How do you find, children? We have to subtract 144 from 225. You will get A squared. Okay. Now, A squared is 225 minus 144. That is 81. A squared is 81. But we don't want A squared. We want A. So, how do we find A? Simple. Find the square root of 81. I think all of you can guess what it is. By now, most of you have guessed that A is square root of 81, that is 9. So, this distance between the foot of the ladder and the wall is, children, 9 centimeter. So, these parameters, that is 12, 9 and 15, they satisfy the Pythagoras property. So again we can call 9, 12 and 15. What can we call them? Pythagorean triplets. Why? Because they satisfy the Pythagoras property. Clear? Now your assignment is in page 130, exercise 6.5. So from your own textbook, solve problems from 4 to 8 in your homework books, children.